Greetings everyone. This is the pre-lab for the activity series of metals. As you can see, I have the lab sheet that I handed out to you on Monday. And with this lab, it says some of the chemicals are toxic, so let's assume they all are. One will turn your skin black on contact. If you get any of these chemicals on your hands, wash it off immediately and tell your teacher. Wear your goggles at all times over your eyes, not your forehead or around your neck. Now, if you look at the introduction, we will be taking different metals of this lab and trying to see if they replace other metals. We will be doing a single replacement reaction. So for example, we have three metals here, A, B, and C, and we have their solutions with NO3, the nitrate ion. So A nitrate, B nitrate, C nitrate. Now obviously A will not replace itself, so that's why there is an X right here in that box. Now if I'm looking at this, A did not replace B, nor did it replace C. As I go down, B replaced A. C replaced A. Obviously, once again, B won't replace itself, C won't replace itself. So as I look at the different boxes here, I can see that A did not react with anything. B reacted twice. C only reacted once. So if I were going to set up the activity series of these three metals, I would say B was the most reactive, C was second, A was on the bottom, the least reactive. So that's what I'm looking for in this lab. As I go on to the procedure, we need to take a 24 well plate. That's the one that has 24 containers. It's the bigger of your well plate. The smaller one was the 96 well plate. We're going to be testing one metal at a time. To do so, you put about 20 drops of the four solutions in the appropriate well plates. Now, what do I mean by the appropriate well plates? As I go down here to my data table, here is my 24 wells. Actually, this is 1, 2, 3, 4, 5 times 5. That's 25, but it doesn't matter because you'll see that we are not doing silver. Number one, we won't be doing silver because it is a very expensive metal. We're not going to waste the money. Number two, we will be able to see how reactive silver was over here because we'll already be testing it with all the other metals. So, if I'm looking on my well plate, let's say that this is A1, okay, B1, C1, D1, E1. We have the appropriate things in the appropriate wells. Now, I'm not going to try to react magnesium with magnesium nitrate. And if you look at this, obviously that is not the correct formula for magnesium nitrate. Some of these might be correct, some of them might not. You better double check those based on your knowledge of writing formulas. Okay? So if I look, here is well plate A2. So in this well, I will have 20 drops of magnesium nitrate, and I'm going to add zinc metal into that. In A3, I'm going to have 20 drops of magnesium nitrate and iron metal in that. 4 down here is going to be the magnesium nitrate, 20 drops with the copper metal. And finally, number 5, we will not be doing, okay? So this one, you're going to have to determine, once again, based on your results that you get over here, all right? If you have a question when we're completed, go ahead and come up and ask me, and I will walk you through, okay? So you should have nothing in the wells where you see the X's. There will not be anything in those wells because, like I said, we're not going to try to react iron with iron 2 chloride. We know it's not going to work. Iron will not replace itself. So as I head back up to my procedure, I put the 20 drops in their appropriate places. I can do these in any order, folks. We've only got 5 bottles back there. Let's make sure that we use our time wisely. If there's an open bottle, we can get it and we can put our 20 drops in. We know what wells they go in now. Says that we need to make sure that the surfaces of the metal are clean and shiny. So I have sandpaper. If you need to use the sandpaper to shine them up, make sure you do so. Place the metals in the solution that you have and wait at least 2 minutes to see if a reaction occurs. Evidence may include bubbling. There may be a change in color. The solution may change color, or the size or the shape of the metal may change. Sometimes when the metal gets wet, it changes color or appearance. Make sure that you are not reading that as a color change and mistaking that for a reaction. We need to test all 4 of the metals. Like I said, the 5th metal does not get tested. It's too expensive. When you are completed, you need to record the results of each test in your data table using the same abbreviations as what we did in the example in the introduction. Either it's an NR for a no reaction, or it's a RXN for a reaction. When we're completed, at the back of the lab, I have a tub that you will put all the waste in, including the metals. It says to rinse the metal pieces at your sink and dry them thoroughly and put them back. We won't be needing to do that. Just take all of your waste and put them into the appropriate tub in the back of the classroom. Make sure you clean your 24 well plate completely and dry it and put it back into your desk or your lab drawer, excuse me. Now, when you're answering the questions, you're going to need to write the balanced equation for each of the reactions that occur. Hint, there should be 10 reactions. If you didn't get 10 reactions, something might have been amiss. That doesn't matter. You can only go by what you saw. So if you only got 8 of these, I guess you only write 8 reactions down. But there should be 10 reactions that you saw. Go ahead and write the balanced equation for those reactions right here after you've cleaned up the lab.